Hi guys, it's a pleasure to be here with you. Today, we're going to start with a new lesson. And for this lesson, we're going to begin with learning. We're going to learn how to identify the constant of proportionality in equations. This is on page number 41. And it says, two quantities are proportional if the ratios comparing them are equivalent. If we remember what a ratio is, remember that we have two quantities and we want to know the relationship between them. Okay. For example, if I'm going to use 2 cups of flour, I need to use 1 cup of sugar. Okay, that's the ratio. For every 2 cups of flour, I need 1 cup of sugar. So if I'm going to use 4 cups of flour, I will need 2 cups of sugar. Okay, those are the ratios. And this ratio is called the constant of proportionality. Proportional relationships can be represented by an equation in the form of y, it's equal to kx, where k is a constant of proportionality. Okay, so a linear relationship is proportional when the ratio of y to x is a constant k. Good. Now in symbols, y it's equal to kx. Remember where k it's not equal to 0. And we have an example here. Y, it's equal to 3x. What does that mean? That when I have one amount, or my quantity is 1, I will have 3, or it will be 3 of that quantity, okay? If this one will be 1, 3 times 1, it's 3. So y will be 3. Remember, 3 right here. Well, I'm going to put it like in with a straight line. 3. Y will be 3 when x is 1. Okay, this is what we did, graphing. Okay, good. Let's see an example. Example number 1. And it says, identify the constant of proportionality in equations. And it gives us an example, a problem. Okay, Olivia bought 6 containers of yogurt for $7.68. The equation y equals to 1.28x can be used to represent this situation, where y represents the total cost of the yogurt and x represents the number of containers bought. Identify the constant of proportionality, then explain what it represents. So we know that she bought 6 containers. And for those 6 containers, she paid 7.68. Okay, this is what she paid, and this is the number of containers. So we need to find the constant of proportionality. What is that? Well, we need to find out how much does each of these containers it's worth. Okay, so how can we do that? We can do a division. 7.68 divided by 6. Okay, that will give us, when we do it, it should give us a constant of proportionality, which is 1.28. Look at this. And the formula. What do we see of similarities? Well, that 1.28, the constant of proportionality, tells us how much each container it's worth. So we need to identify the constant of proportionality, which we did right here, and we need to compare the 2 equations. Y, it's equal to kx, where k is the constant of proportionality. In the equation for the cost of the yogurt, the constant of proportionality is 1.28. How did we get it? Well, we did a division, okay? In part B, it says, now explain the constant of proportionality. The constant of proportionality has the same value as the unit rate. Remember what a unit rate is. How much is for each unit, okay? So the constant of proportionality means that the cost for each container, each unit, each container of yogurt will be 1.28. So the constant of proportionality is 1.28, and the unit rate, it's also 1.28 per container. Okay? Now, we're also going to learn about proportional relationship and equations. You can use the concept of proportionality or unit rate to write an equation in the form of y equal kx. That represents a proportional relationship. You can find k by writing the ratio comparing the y to x. To write the ratio, solve the equation y equal kx for k and write the equation. So we're going to write an equation for k. K, remember in this case, k represents the constant of proportionality. So what we need to do is we need to solve for k. We don't have any letters, but we don't have any numbers, but we have letters. So right here, these two are multiplying. So we need to undo this operation by dividing. We're going to divide by x, both sides. Everything you do in one side of the equal sign needs to be done in the other one. So in this side, we only have k left. And in this side, we have y divided by x. Okay, so the constant of proportionality is the ratio of y divided by x, where x, it's not 0. Okay, let's see how it works. Let's see an example of this. In example number 2, we see the following. JC bought 8 gallons of gas for $31.12. Write an equation relating the total cost, y, to the number of gallons of gas, x, if it is a proportional relationship. Find the constant of proportionality between costs and gallon. So we need to do the same thing, right? We need to divide. How much would it be for 1 gallon? So we do the division. 31.12 divided by 8 is 3.89 divided by 1, which means that the constant of proportionality will be 3.89. That means that the total cost is 3.89 per gallon. Okay, that's per gallon. Now, in step 2 says write the equation. The total cost is 3.89 multiplied by the number of gallons. Let y represent the total cost and x the number of gallons. So my equation would be, to find out the price, we need to multiply 3.89 by the number of gallons that we're going to get. Why? Because 3.89 is the amount each gallon costs. Okay, so that way we can know how much we're going to pay for X amount of gallons. Okay, good. Let's see another example to make it a little bit more clear. Proportional relationships and equations. The perimeter of a square is proportional to the length of one side. A square with 10-inch sides has a perimeter of 40 inches. Write an equation relating the perimeter of the square to its side length. Then find the perimeter of a square with a 6-inch side. In part A, we need to write an equation. So the perimeter of a square with 10-inch sides is 40 inches. What is the relationship? So if we know that each of the sides, it's 10 inches, and the perimeter is 40 inches, we need to find first or write a ratio that compares the perimeter to the side of the length. Okay, so it will be 40 to 10. Okay, this will be the perimeter and this will be the side. Now we need to find the constant of proportionality. So what do we need to do is we need to make a division. Okay, if 40 is a total, we need to divide it by the side. 40 divided by 10 will get a 4. So the constant of proportionality is 4. Okay, good. Now, the next part of the problem says the perimeter, we know by doing this that the perimeter is 4 times the length of a side. So the equation is written as y equals 4x. Use the equation to find the perimeter of a square with a side of length of 6 inches. Now that we know that to find the perimeter, we need to multiply the side length times 4, we can find any perimeter of any square if we have the length of one of the sides. So instead of x right here, okay, we're going to put 6 inches, which we already know, and we multiply. 4 times 6, it's 24. So the perimeter of the square with sides of 6 inches is 24 inches. Okay, good. Remember, you have to be watching this and doing the examples in your book and also doing the checks in your book. All right? Good. Now, to finish this up, we're going to do an application. So for this application, we're going to find a way to solve it. And it says, Hugo can run 4 miles in 25 minutes. How many more miles can Hugo run in 90 minutes than in 25 minutes? And it says, assume the relationship is proportional and he runs at a constant rate. So the first thing we need to do is we need to find the constant of proportionality to make our equation. Okay? So we know that he can run 4 miles in 25 minutes. So we need to find out, since we know that he is going to run in 90 minutes, we need to find out how much does he run per every minute. Okay, to find out the miles. So we need to divide the 4 miles in the 25 minutes to find out how much would he run each minute. We need to find the unit rate or the constant of proportionality, which is the same thing. So when we divide 4 by 25, we find out that every minute he runs 0.16 miles. So that will make us make our equation. Y, it's going to be equal to 0.16x, where x represents the minutes, okay? So we want to know how much can he run in 90 minutes. What we need to do, instead of this x, we're going to write a 90. So this will be 0.16 times 90. When we multiply 0.16 times 90, we get 14.4. Oh, I put 0.9, it's 0.4. That means that in 90 minutes, he runs 14.4 miles. But the question says, we go back to the question, and the question says, how many more miles can Hugo run in 90 minutes than in 25? How many more? So we already know that in 25 minutes, he runs 4 miles. And we also know that in 90 minutes, he runs 14.4 miles. So how many more miles he runs in 90 minutes? Well, we do a subtraction. 14.4 minus 4 will give us a total of 10.4 miles. So that's how much he runs more in 90 minutes than in 25 minutes. All right? Remember, there are several ways to get to this answer. You can do it the way you find it better. This is a way I wanted to show you, but remember that you can do it the way you find it best. All right? Excellent. Well, now is your turn. You need to do your application 2 on page number 46. And make sure that you have every single check from pages 40, I think it's 41. Let me see. Yeah, 41 to 46, right? And I'll see you tomorrow, and have a wonderful day.